Hello, good morning. I'm discussing about classification of electroanalytical methods. Electroanalytical methods are classified as following: electrogravimetry, coulometry, conductimetry, amperometry, potentiometry, polarography. First of all, electrogravimetry. Electrogravimetry measures the mass change of an electrode due to the deposition of an analyte. According to Faraday's law of electrolysis principle, electrolysis carried out, properties measured, material deposited on one of the electrode is weighed. For example, electroplating to determine metal ion concentration. Coulometry. Coulometry measures the total charge passed through the system during an electrochemical reaction. Coulometry measures the total charge passed through the system during an electrochemical reaction. Principle: deposition of matter on an electrode during electrolysis. Properties: quantity of electricity and time. For example, determination of water content by a Carl-Fisher titration. Conductimetry, change in electrical conductivity of a solution during chemical reaction, and measure electrical conductivity. Change in electrical conductivity of a solution during chemical reaction and measure electrical conductivity. Principle: change in electrical conductivity of a solution during chemical reaction. Okay. Change in electrical conductivity of a solution during chemical reaction. Properties: electrical conductivity, electrical resistance. Conductivity measures the conductivity of a solution to determine the concentration of ionic species. For example, monitoring water purity. Amperometry, a potential applied between the indicator electrode is kept constant. Amperometry is used to measure current through the electrolytic cell. Amperometry is used to measure current through the electrolytic cell. Principle: potential applied between the indicator electrode and polarized reference electrode is kept constant. Properties measured: current through the electrolytic cell is measured. Amperometry measures the current generated by the oxidation or reduction of an analyte at the constant potential. For example, glucose sensor in blood analysis. Potentiometry: it is change in the electrode potentials of the system during chemical reaction or the measurement of electrical potentials is a technique in chemical analysis. Measurement of electrical potential. Principle: change in electrode potential of a system during chemical reaction. Property measure electrode potential. Potentiometry measures the electrical potential of a solution without passing a current. For example, pH measurement using a glass electrode. Polarography. Polarography is based on electrode polarization. Electrode polarization means electrochemical reduction oxidation principle and explained using Ilkovic equation. Polarography is used to measure electrode potential, voltage, current. Principle: electrode polarization. Properties measure voltage, current. Electrode polarization refers to a phenomenon that occurs during the electrochemical process when the behavior of an electrode deviates from ideal electrochemical behavior due to various factors like overpotential and concentration gradient at the electrode interface. Work potential occurs when the applied potential at the electrode solution interface is different from the thermodynamic potential required for an electrochemical reaction to proceed. This additional potential is needed to overcome the activation energy barrier for the reaction. Work potential can lead to slower reaction rates and can be influenced by factors like electrode surface properties, temperature, and the nature of the electrochemical reaction. Concentration gradient or polarization occurs due to the accumulation ions or molecules near the electrode surface during an electrochemical reaction. As the reaction proceeds, the concentration of these species can change, leading to a concentration gradient at the electrode. This gradient can create an additional potential difference that opposes the desired electrochemical reaction. Concentration polarization can be decreased by stirring the solution or using a rotating electrode to improve mass transport to and from the electrode surface. Polarography is used to measure electrode potential, voltage, and current. Okay. Polarography principle: electrode polarization, measured voltage, current. Potentiometry, change in electrode potential, electrode property measure electrode potential, potentiometry. Amperometry measures current through the electrolytic cell. Conductimetry, change in electrical conductivity of the solution during chemical reaction. Coulometry, deposition of matter on the electrode. Property measure quantity of electricity. Electrogravimetry measures the material deposited on the electrode. Principle electrolysis carried out. So electrogravimetry. Electrolysis, coulometry. Deposition of matter on the electrode during electrolysis. Conductimetry, electrical conductivity, amperometry, current through the electrolytic cell, potentiometry, measurement of electrical potential, polarography, electrode potential polarization. Electrode polarization, it measures voltage in current. It's all about classification of electroanalytical methods. Thanks for watching, and request you all like, comment, share, and subscribe. Thank you for your patience. That is now. Bye bye. See you again.